Hi, everybody. Ms. Lee here. We're going to go ahead and go over a specific concept. Basically, we're going to be talking about signs of the 6 trig functions in each of the different quadrants. And then I will go over an example of how to find the values of the 6 trig functions given one of the values and the quadrant that it's in. Okay, basically, the question that I'm about to answer is which trig functions are positive in which quadrants? Okay, and so we have a little mnemonic for remembering it. So basically, as y'all know, for the quadrants, we have the first quadrant right here, and then we go counterclockwise. And so this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, so you should already know that. And so that's basically the way we count, just in that counterclockwise circle. And so there's this mnemonic. It's basically all students take calculus. So all students take calculus, or all scientists teach calculus. There's like all these different things that you can use to remember it. But basically, all of the trig functions are positive in the first quadrant. Then only sine, and then only tangent, and then only cosine are positive in each of these other ones. Okay, so generally we use the mnemonic all something, take calculus or something of that nature to remember which ones are positive in which quadrant. And of course, since these trig functions are paired with a reciprocal function, those will also be positive in each of these the corresponding quadrants. So for sine, cosecant will also be positive. For tangent, cotangent will also be positive. And then for cosine, secant will also be positive. Okay, so we'll go ahead and keep that in mind when we are doing working with the unit circle and the trig functions. So let's go ahead and do an example then. So we're going to find the values of the 6 trig functions. Oopsies. Of theta, given that cosecant of theta equals -7/2, and then theta is going to be between 3 pi over 2 and 2 pi. Okay, so when you see a problem like this, what you're supposed to read is that theta, because it's between 3 pi over 2 and 2 pi, that would mean that it's in the fourth quadrant. Okay, so we're in the fourth quadrant, which is right here. This is the fourth quadrant. And so you want to be able to interpret that yourself. So this is the fourth quadrant. And then we'll go ahead and draw that in. So if you just do a quick sketch of your axes, what you're going to do is you're going to draw some ray, and we're going to create our angle. So we're going to create a reference angle. And with the reference angle, you're always going to use the nearest x-axis. So you never draw it to a y-axis. You always draw it to the closest x-axis. So the closest x-axis is right here. And so this is going to be our reference triangle. And so this here will be our reference angle. So we're going to say theta with a little r subscript. And that's because this is the angle that we're going to be using to figure out our values, but that's not the actual angle. So the actual theta is going to be from here to here. But since that doesn't make a triangle, it's not super helpful to us. So we'll go ahead and label this triangle as we can. So if cosecant of theta equals -7/2, what we can do, I'm going to go ahead and just draw this triangle a little bit larger. What we can do is we can say that means that hypotenuse over opposite equals -7/2. Okay, so hypotenuse, we always make that positive, so we'll put the hypotenuse as 7. And then opposite, we'll make that -2. And this also makes sense because this is going down, so this is a negative y value, and so therefore that's going to be negative. We're labeling that as negative. And you'll want to use the Pythagorean theorem to figure out what the other side length is. So since it's going to be, let's just call it x, so we have x squared plus -2 squared equals 7 squared. What we have then is x squared plus 4 equals, and then 49. And so x squared equals 49. And so, sorry, x squared equals 45. And so x equals plus or minus square root of 45. So because the x value here, this x is on the positive x-axis, this is going to be the positive. And so we have x equals square root of 45, which if you simplify this, you would write it as x equals square root of 9 times 5, which is equal to 3 root 5. Okay, so this side over here is going to be 3 square root of 5. All right, so then we can go ahead and write out our 6 trig functions. So our 6 trig functions are sine of theta, cosine of theta, tangent of theta, cosecant of theta, which was given, so that should be straightforward, secant of theta, and then cotangent of theta. Okay, so cosecant of theta was given, that's -7/2. Which means that you can then figure out what sine of theta is just based on flipping that to its reciprocal. So the reciprocal of -7/2 is -2/7, so that's sine of theta. And then for cosine of theta, that'll be adjacent over hypotenuse, which is 3 root 5 over 7. Tangent of theta is opposite over adjacent, and so you have -2 divided by 3 root 5. Secant of theta, we'll go ahead and flip this. But since if you flip that, it's not going to be fully rationalized, we're going to want to rationalize that. So let's go ahead and flip cosine of theta. So you have 7 divided by 3 root 5. And so we'll multiply the numerator and denominator by square root of 5. And so in the numerator, you have 7 root 5. And then in the denominator, you have 3 times, and then root 5 times root 5 is just 5. And so you have 7 root 5 over 15. So that's 7 root 5 over 15. Oopsies, it looks like we didn't rationalize the tangent one, so we'll have to rationalize that. But let's go ahead and flip it first to do the cotangent. So when we flip it, we have negative 3 root 5 over 2. So that was just the flip of that. But let's go ahead and also rationalize the tangent. So tangent of theta was -2 over 3 root 5. So we're going to multiply the numerator and denominator by square root of 5. And so we have -2 root 5 divided by 3, and then times root 5 times root 5. So root 5 times root 5 is 5. So then it's going to be 3 times 5, which is negative 2 root 5 over 15. So this here is going to be negative 2 root 5 divided by 15. Okay. And there we have it. We have now evaluated all of the remaining trig functions given one of the trig functions and a quadrant. Go ahead and put in the chat if you have any questions, or go ahead and try the practice problems. Happy day.